When British troops hit the Normandy shores in June 1944, they were armed with a rifle that had been around for almost half a century. The short magazine Lee-Enfield, created in 1895 and officially introduced in 1907, remained the primary weapon for Commonwealth forces. At the same time, their German enemies used the Carabiner 98K, an improved version of the famous Mauser action that had been refined over many decades. In theory, this made no sense. The German weapon was more precise at distance, featured more contemporary materials, and represented what numerous firearms specialists viewed as the ultimate bolt-action configuration. Still, British troops who seized German rifles during battle often discarded them and stuck with their Lee-Enfields. This wasn't about emotions or being stubborn. It was practical battlefield wisdom, earned through real combat experience. The Lee-Enfield's history starts in the 1880s, when British military leaders realized they needed a repeating rifle that used smokeless powder. James Paris Lee, an inventor from Scotland and Canada, had created an innovative detachable box magazine mechanism. Combined with the barrel rifling developed at the Royal Small Arms Factory in Enfield, this produced the magazine Lee-Enfield. After its first deployment in the Second Boer War, multiple versions led to the short magazine Lee-Enfield Mark III appearing in 1907, the legendary SML Lee that would serve in 2 world wars and numerous colonial battles. What kept this rifle relevant for nearly 100 years wasn't one groundbreaking feature, but several practical design decisions that focused on what truly counted in battle. Military doctrine at that time stressed long-distance precision. European military forces were fixated on engaging targets at 800, 1,000, or even whomps at 500 yards. The Germans especially valued marksmanship, and their Mauser rifles embodied this approach with extended barrels and precise manufacturing standards. The British chose a different path with the SMLE. They reduced the barrel length to only 25.2 inches, making the weapon more maneuverable in trenches and vehicles. They sacrificed some long-distance accuracy because their battlefield analysis revealed that most infantry combat occurred within 300 yards. This contradicted European military thinking, but proved accurate when trench warfare reality emerged after 1914. The weapon's rear-locking bolt configuration puzzled firearms specialists. Most service rifles, the Mauser included, employed a front-locking design where lugs near the chamber handled firing pressure. The Lee-Enfield's lugs were positioned at the bolt's rear, which, in theory, made it less robust and less precise. Detractors claim this configuration could never achieve Mauser-level accuracy. They were correct on shooting ranges, but combat zones aren't shooting ranges, and the Lee-Enfield's configuration offered benefits that mattered more than reducing group sizes by fractions at 600 yards. The extended bolt movement needed for the rear-locking mechanism actually allowed quicker cycling, and the action handled contamination and fouling better. By 1939, when Britain faced Germany in war once more, the SMLE was technically outdated. Yet, manufacturing increased rather than decreased. Plants in Britain, India, and Australia produced millions more units. British military leaders weren't holding on to the past. They understood that impressive engineering specifications didn't always mean combat superiority. The British military had a training benchmark that sounded absurd when recruits first learned about it. Every soldier needed to fire 15 accurate shots per minute from their bolt-action Lee-Enfield. The most proficient could reach 30 rounds. This was known as the Mad Minute, and it wasn't some training exercise for show. It was a core tactical principle that would protect the British Expeditionary Force during the early stages of World War I. On August 23, 1914, at the Belgian town of Mons, approximately 70,000 British soldiers confronted nearly 160,000 German forces. The Germans anticipated a swift triumph against what they thought was a limited, obsolete force. Instead, they encountered such devastating rifle fire that German officers thought they faced hidden machine guns. They didn't. They faced British riflemen, executing precisely what their training had prepared them for. The SMLE's mechanism was engineered for rapid operation. The bolt handle was positioned at a 60-degree angle instead of the 90 degrees typical of most service rifles. This reduced bolt throw meant minimal motion between rounds. Your grip remained comfortable without excessive wrist movement. The weapon's rear locking bolt required cocking the firing pin when closing rather than opening, which felt more natural during quick firing sequences. When opening the bolt, the empty cartridge ejected cleanly without fighting against mainspring compression. You concentrated solely on chambering the next cartridge. This mechanism, paired with intensive training, turned individual soldiers into formidable firing units. British marksmanship instruction was probably the world's most rigorous. Recruits dedicated weeks to range practice before learning other combat skills. They mastered firing from standing, kneeling, sitting, and prone stances. They drilled magazine replacement until they could insert a fresh 10-round magazine in less than 3 seconds. They learned to judge distance visually and modify their sights accordingly. The SMLE's ladder sight arrangement, though appearing primitive compared to German systems, was actually quicker to modify under pressure. You moved a lever, adjusted the sight to your needed range mark, and secured it. No detailed adjustments, no hesitation, just battle-ready speed. The Mad Minute qualification demanded placing rounds on a 12-inch target at 300 yards 15 times within 60 seconds. That meant loading a new magazine during the exercise while maintaining precision. Soldiers achieving 20 hits received marksman recognition. The famous Sergeant Instructor Snoxall allegedly scored 38 hits in a single minute during a 1914 presentation, though this needed an assistant supplying him with loaded magazines. The objective wasn't setting records. It was developing muscle memory so profound that quick, accurate shooting became instinctive under battle stress and confusion. At Mons, German forces advancing in formation fell at distances where effective return fire was impossible. After-action accounts describe complete German companies being halted by what they truly believed was continuous machine gun fire from several locations. Actually, groups of 8 to 10 British riflemen generated that firepower. A captured German lieutenant later that week told questioners he'd measured the firing rate and calculated his unit faced at least 20 machine guns. He couldn't believe that bolt-action rifles could create such sustained fire. The British fielded just 4 machine guns per battalion at Mons. Everything else was rifles, training, and the SMLE's quick fire capability, doing precisely what it was built for. Trench combat was a weapon engineer's worst nightmare. Everything that appeared refined in factory testing became a problem when exposed to Western Front realities. Rifles endured days and weeks in rain, snow, and the distinctive corrosive mud of Flanders, a thick clay mixture that penetrated every opening. Soldiers couldn't service their weapons according to peacetime manual recommendations. There was no warm armory, no sanitary workspace, no availability of proper cleaning materials. You removed what moisture you could shake loose, perhaps a cloth if fortunate, and whatever oil hadn't been consumed weeks earlier. Under these circumstances, the Lee-Enfield performed exceptionally. Its generous tolerances meant dirt didn't jam the mechanism, while German Mausers required meticulous maintenance to function reliably. The SMLE kept firing. British soldiers discovered they could literally knock mud from the action with a rifle butt, work the bolt several times, and resume shooting. The weapon's rear-locking lugs and 10-round magazine design contributed to this durability. Since chamber pressure didn't directly stress the lugs during firing, they tolerated more wear and fouling. The larger magazine capacity meant fewer reloading cycles during extended engagements, reducing opportunities for debris to enter the action during vulnerable magazine changes. Field reports from the Somme in 1916 document Lee-Enfields pulled from flooded trenches that still functioned after basic cleaning. One account describes a rifle recovered from a shell crater filled with water and mud. After draining water from the barrel and working the bolt to clear the action, the weapon fired successfully. Attempting this with a Mauser usually resulted in a jammed rifle requiring armorer-level disassembly. The North African campaign between 1940 and 1943 demonstrated the Lee-Enfield's capabilities in completely different extreme conditions. Desert warfare brought sand, temperature swings from freezing nights to scorching days, and constant grit that destroyed precision equipment. Sand is particularly destructive to firearms. It's abrasive enough to accelerate wear on moving parts and fine enough to work into the smallest gaps. Tight tolerances that enhance accuracy in ideal conditions become vulnerabilities when sand enters the equation. Australian and New Zealand forces at Tobruk battled through sandstorms that limited visibility to arm's length. When the sand settled, their rifles remained functional. The Italian Carcano rifles, used by enemy forces, frequently locked up entirely after sandstorms, needing complete breakdown. Even the Mauser required substantial cleaning before dependable operation resumed. British armorer documentation from the Tobruk siege noted that Lee-Enfields returned for maintenance with sand literally packed inside the mechanism. Yet, most still operated adequately for combat. One account from August 1941 recorded a rifle that had discharged over 200 rounds across a 3-day battle without cleaning and remained serviceable when finally examined. Burma and the Pacific Theater introduced contrasting extremes: heavy monsoon downpours, jungle moisture that kept metal constantly wet, and mud that made Flanders seem dry by comparison. The British 14th Army, operating in Burma from 1942 to 1945, worked in environments where metal oxidized overnight and wooden stocks expanded from moisture penetration. Japanese Arisaka rifles, well-engineered weapons themselves, struggled with humidity impacting their chrome-lined barrels and creating feeding problems. The SMLE's standard bore needed more regular cleaning, but showed less susceptibility to the erosion and corrosion that affected chrome barrels when coating failed. The walnut furniture absorbed humidity without the extreme expansion that impacted the denser woods used in Japanese and certain German rifles. British forces operating in the Arakan and along the Chindwin River frequently went weeks without adequate weapon servicing facilities. Sergeant Charles Carfrae of the Border Regiment described his rifle following 3 weeks of non-stop jungle combat in early 1944. The metal showed surface oxidation. The stock had darkened almost to black from moisture and use, and the barrel was dirty from hundreds of rounds without thorough cleaning. Still, when his unit attacked Japanese defenses at the Ngakyadak Pass, the rifle worked flawlessly. Carfrae noted that he'd observed captured Japanese rifles in much better visual condition that wouldn't operate reliably because moisture had impacted their tighter mechanisms and produced feeding failures. The Arctic offered another challenge. British and Canadian forces deployed in Norway in 1940, and subsequent Allied troops in Northern Europe during winter 1944-45 encountered temperatures dropping below 0 Fahrenheit. Lubricants became gel. Metal shrank. Moisture froze immediately. The German approach was using minimal lubrication and specialized cold weather oils. But this demanded specific supplies not always accessible to frontline soldiers. The British approach was simpler. Strip all oil from the Lee-Enfield's mechanism and operate it dry. The weapon's configuration enabled it to work without lubrication in severe cold. Canadian forces fighting in the Scheldt estuary during November 1944 reported their Lee-Enfields operating consistently in sleet and freezing precipitation that left German prisoners' rifles frozen and unusable. The smooth opening mechanism meant less force needed to operate the bolt, which mattered when metal contracted from cold and every action required additional effort. The Lee-Enfield service record tells a narrative that challenges conventional thinking about military technology. The rifle joined British service in 1895 as the magazine Lee-Enfield, transformed into the SMLE in 1907, and stayed the standard British and Commonwealth infantry weapon throughout World War II. But its history didn't conclude in 1945. India kept producing Lee-Enfields until the 1980s. The rifle witnessed action in Korea, Malaya, Kenya, Suez, and the Falklands. Canadian Rangers in the Arctic still carried the No. 4 Mark I variant until 2015, 120 years after the Lee-Enfield configuration first emerged. No other military bolt-action rifle comes close to this service span. The Mauser 98K, despite its technical superiority, was replaced within years of Germany's surrender. The American Springfield 1903, the Japanese Arataka, the Soviet Mosin Nagant, all were retired within one generation after World War II ended. Only the Lee-Enfield continued. This endurance wasn't sentiment or administrative stubbornness. It was acknowledgement that the rifle achieved the fundamentals correctly in ways that mattered more than specifications indicated. The British hadn't attempted to create the most accurate rifle or the most precisely produced rifle. They'd created a rifle optimized for what infantry combat actually demanded: continuous rapid fire, dependability in harsh conditions, and straightforward operation under pressure. These priorities seemed almost ordinary compared to the Mauser's engineering sophistication, but they proved more worthwhile than precision that most soldiers couldn't utilize. The SMLE embodied a philosophy that practical effectiveness outweighed theoretical excellence. Modern military firearms development has consistently relearned the Lee-Enfield's principles. The M16 rifle's initial problems in Vietnam stemmed partly from tight tolerances that caused the weapon to malfunction in jungle environments, the identical problem that troubled the Mauser in mud and sand. The fix involved relaxing tolerances and introducing chrome lining, essentially implementing principles the SMLE had incorporated since 1907. The AK-47's famous reliability derives from loose clearances that allow it to operate when contaminated with debris, exactly what enabled the Lee-Enfield to work in trenches 70 years before. Modern military thinking emphasizes firepower volume and quick engagement at closer distances rather than long-distance precision shooting. The identical philosophy that prompted Britain to favor the Mad Minute over 1,000-yard accuracy. The rifle's narrative provides wider insights about military technology and acquisition. Advanced engineering doesn't automatically equal battlefield advantage. The Mauser was objectively more sophisticated in its construction. Controlled feed, twin front-locking lugs, superior metallurgy. But sophistication introduces complexity, and complexity introduces weak points. The Lee-Enfield succeeded through simplicity and resilience. Its generous tolerances, rear-locking bolt, and uncomplicated operation made it simpler to employ and more difficult to disable. Soldiers didn't require expert gunsmith skills to maintain it functional. This matters because conflicts are fought by draftees and part-time soldiers, not exclusively professional troops. A weapon that only excels in skilled hands is less useful than one that works adequately in any hands. The economic insight is equally important. Britain manufactured roughly 17 million Lee-Enfields across all versions from 1895 through the 1950s. The production method employed simpler equipment and less exact machining than the Mauser needed. This meant manufacturing facilities could be established quicker, personnel trained faster, and production expenses kept lower. During World War II, when industrial output determined how many rifles an army could deploy, the SMLE's manufacturability became a strategic benefit. Germany manufactured excellent rifles, but never sufficient quantities. Britain produced adequate rifles in enough volume to equip not only its own troops, but supply weapons to resistance groups and partner nations around the world. Sufficient adequate weapons surpass limited superior weapons. The Lee-Enfield demonstrated that aged doesn't mean useless and contemporary doesn't ensure improvement. It demonstrated that comprehending how soldiers actually engage matters more than theoretical capabilities. Most significantly, it demonstrated that the optimal weapon isn't the one winning design awards. It's the one continuing to function when everything else has stopped. That soldiers depend on with their lives, and that brings them home safely. The British soldier's choice of his older rifle over German contemporary weapons wasn't being stubborn. It was understanding.